All right, in this video, we are going to be continuing with hydrocarbons. As a reminder, hydrocarbons are organic molecules that contain only hydrogen and carbon, and we use table P and table Q to name them. Table P gives us the prefix that correlates to the number of carbon atoms, and then table Q, depending on whether or not we have an alkane, alkene, or alkyne, that tells us what ending to use. In this video, our hydrocarbons are going to have some branches coming off of them. So instead of just being in a straight line, they'll have some carbon groups coming off of them. So we'll learn how to draw them and name them. So if we take a look at this first example here, we have what's called 4-methyl octane. So the steps in order to name this is to find your longest continuous carbon chain. So continuous does not necessarily have to be a straight line. Continuous means that we can connect it without picking up our pen or pencil, which happens to be a straight line here, but it would be possible that it could curve as long as you don't pick up your pen or pencil. So you find your longest continuous carbon chain and then name it. We have 8 carbons there, so that is where the octane part comes from. And they're connected with single bonds, so that's why it's ane for the ending. Then that leaves behind this carbon chain. That's a branch. Branches get a YL ending, and then inside my branch there's 1 carbon, so it's a methyl branch. If it was 2 carbons long, it would be an ethyl branch, 3 carbons long, propyl, and so on. So that's where the methyl comes from. Then the number is where it's located. And just like with our regular hydrocarbons, you have to check numbering from either end of the chain. So if we went from left to right, the branch would be off of the 5th carbon, or going in reverse direction, it would be off of the 4th. The correct answer is whatever gives us the lowest set of numbers. So 4-methyl octane, this would be. Now, if I had just given you the name 4-methyl octane, now if I gave you the name 4-methyl octane, you could draw the mirror image of this. So you could just do your 8 carbons, 1, 2, 3, 4, 5, 6, 7, 8, connected with single bonds. And then off of carbon 4, you could put your methyl group. So when I give you the name, you can just number it normal left to right. It's only when you're given the picture and you have to come up with the name that you need to check numbering from both ends. And then if you were drawing this one, you would still need to go back in and add all of the H's so that it contained the correct number of hydrogen atoms. All right, so these slides here just summarize what we went through. So you find your longest continuous carbon chain and name that. Again, continuous will often be a straight line, but it could curve and bend as long as you don't pick up your pen or pencil. Then anything that's left over, I circle. Those will be my branches. Branches end in YL. And then depending on how many carbons are in the branch, that tells us what the name would be. And those would correlate again with table P. So 1 carbon, prefix is meth, so it's a methyl branch. 2 carbons, prefix is eth, so it's an ethyl branch. And 3 carbons, prefix is prop, so that makes it a propyl branch. And again, we have to use numbers. So the location of the branch group has to be indicated. We've talked about how you have to number from whichever end will give you the lowest set of numbers. So if you have multiple ones, you want to do what sums up to the lowest, or if you just have one, you go with the lowest. If there's more than one of the same branch, then we'll use prefixes. So instead of saying methyl, methyl, methyl hexane, because that just sounds ridiculous, you would say trimethyl hexane. And then there would be 3 numbers out in front to give the location of all 3 branches. So now we just have some examples to do. So our first example is 2,2,3 trimethylpentane. All right, so when you see these names, you need to break them down very systematically, and then it becomes actually quite easy. So we are always going to start at the end of the name. So we are going to start with the pentane part. Specifically, we're going to start with pent, because that's going to tell us how many carbon atoms are in my main chain. So pent, table P, tells us we have 5 carbon atoms. So we go 1, 2, 3, 4, 5 carbon atoms. Ane tells me that I have an alkane, meaning those carbon atoms are connected with single bonds. So that gives me pentane. Now I start moving through the rest of the name. YL tells me that I have a branch. Meth tells me how many carbons are in my branch. So I have branches that are 1 carbon long. Tri tells me that I have 3 1-carbon branches. And then the numbers tell me where they come off of. So off of carbon 2, I have a methyl branch. Off of carbon 2, I have another methyl branch. And then off of carbon 3, I have a 3rd methyl branch. And it doesn't matter if you pointed that one up or pointed that one down. So that's the methyl, 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 which we would call trimethyl. So once you have done that, that is all of the hard stuff out of the way. Now you just go back and you add in the appropriate number of H's. So remember, every single carbon atom needs to have 4 bonds. So you go back, you add in enough H's so that every carbon atom, even the ones in the branches, have 4 bonds. And sometimes it gets a little bit crowded and you might want to angle some of the hydrogens. All right, my formula for this, my molecular formula would be C8. So you count all of the C's and all the H's. So the 5 in the main branch plus the 3 that are coming off. And then you count the H's, and we should have 18 H's. Now, that's going to be very important because it's very easy to miss some H's in here. So you want to check this against your general formula that's listed on table Q. Since this is an alkane, it should be CnH2n plus 2. So however many C's I have double plus 2 H's, which I do. Here is our next example. We have 2,4-dimethyl-3-ethylheptane. Again, when you look at that, that looks very overwhelming, but we're just going to dissect this one part at a time. So we start with the heptane part. Specifically, we start with hept. We look at table P. We see that hept means you have 7 carbons. So we draw 7 carbons in a straight chain. And they have the ane ending, so we connect those with single bonds. So now we are done with the heptane portion. All right, now we move to our next portion, YL. YL tells me I have a branch. So off of this main chain, I've got some carbons coming off of it. F tells me how many carbons are in my branch. So I have a branch that's 2 carbons long, and 3 is where it comes off of. So go to carbon 3, and we have an ethyl branch. Now this is important. You need to have those 2 branches together. So it's either got to be 2 up or 2 pointing down. You don't want to separate it into 1 carbon, because then those would be methyl branches because they'd be 1 carbon long. So in order to be ethyl, they have to be 2 carbons long. So 2 carbons going from either direction, up or down. All right, so that takes care of that part. Now, 2,4-dimethyl, YL, tells us we have a branch. Meth tells me how many carbons are in my branch, so meth correlates to 1 carbon. Di tells me I have 2 1-carbon branches off of the second and off of the fourth. So off of the second carbon, we got a methyl, and off of the fourth, we have a methyl. And it doesn't matter if you had pointed those up or down, but we only have 2 total. So don't put 2 on, both on 2 and 2 on 4. That would give us 4 methyl groups, then that would be tetramethyl. So we only have 2 total. 1 is on the second carbon, 1 is on the fourth carbon. All right, then you're done with that part. Now all we have to do is go back in and add our H's. So every single one of my carbon atoms needs to have 4 bonds. So all of the carbons, even the ones in the branches, need to have 4 bonds. So you add them in, and this part can be a little bit time consuming, but it's not difficult. Then when we are done, we will count up our C's and H's for our molecular formula. So we have a total of 11 C's, so that was 7 in the main chain, then 8, 9, 10, 11, including the ones in the branches. Then we count up all of our H's, and we have a total of 24 H's. And that does fit the general formula for an alkane because we had 11 C's, so we should have double, which would be 22, plus 2 for our number of H's. All right, last thing for this video that we need to talk about are isomers. Isomers are where we have the same molecular formula. So the same number of C's, H's, O's if we happen to have O's, but they have a different structure. So they have a different arrangement of the atoms. So they're going to have a different name. They might be even a different type of compound. And then because of that, they will have different physical and chemical properties. So our example is butane and 2-methylpropane. So butane would be 4 carbons connected with single bonds, and then just with the H's coming off of there. And when we count up our C's and H's for butane, we would have C4H10. I still need to finish down here. Okay, so C4H10. Okay, 2-methylpropane. So we start with propane. So we got 1, 2, 3 C's with single bonds. 2-methyl, we got a branch. Meth is 1 carbon, so we got a 1-carbon branch coming off of the second one. Then I go back, add in my H's. And once I am done adding in my H's, then I check my formula. Whoops, there should be an H up there, a little short on space. And I also get C4H10. So these are isomers because they have the same molecular formula, but they have different structures, different names, which would also give them different physical and chemical properties. All right, when you see an isomer question like this, again, isomer, we're looking for the same molecular formula, so same number of C's, H's, O's, BR's, whatever else you have in there, but a different arrangement. So you just want to compare your formulas. So in number 1, that is not going to work because I only have 1 bromine here and I got 2 there. So they do not have the same formula, plus they don't have the same number of H's. All right, number 2, I got 2 C's and 2 C's, H's, I got 6 in the first compound, and I also would have 6 in the second compound, and 10, 10. So that is going to be my answer because they have the same number of C's, which would be 2, same number of H's, 6, and same number of O's. They each have 10. But they're arranged differently. If I took a look at number 3, that wouldn't work because that one's got 1 C, that one's got 2 C's, plus they have a different number of H's. And number 4 is also not going to work. That's only got 1 C, and that one's got 2.